Hi everyone. Today we are going to be doing lesson 2.10, 2.10. And the name of it is this word here. So just see if you can say it on your own here before I tell you. So it's pronounced stoichiometry for short. Sometimes you'll just see stoic. And, well, let's define what it means. Stoichiometry is calculation problems involving moles, mass, and volume given the reactants and the products of a balanced chemical reaction. So we're going to be using the mole concept as it applies to a chemical equation. And when we do that, then we call it stoichiometry. Okay, so we're going to look at this this equation here. So I've got hydrogen gas and nitrogen gas. These are my reactants. Remember, reactants are on that side. Products are over here, okay? And that's going to produce NH3, so ammonia gas here. Now, your first step whenever you're dealing with anything like this, when you look at a chemical equation, your very first step is always going to be to balance it. So go ahead and balance that equation there. And you should end up with a 2 here. I'm going to have a 3 there. And now this equation is balanced. Okay, so we're going to go run through a series of questions here. So the first one, so how many moles of H2 are there? So looking at these, you're going to get that from the balanced equation here. And so looking at this, there are 3 moles of H2, and that's just that big number in front right there. How many moles of N2 are there? So again, we want to look here, and there's an imaginary 1 there, right? So 1 mole of N2 is there. And part C, how many moles of NH3? 2 moles. Okay, so these are called the molar coefficients, and it gives the mole ratio between all the species in the reaction here. So you're going to have 3 moles of H2 to 1 mole of N2 to 2 moles of NH3, okay? So that's how that works. And now I'm just going to rebalance this here. Okay, so these are pretty easy for people, we're just reading the numbers off, but now we're going to take it a little bit further here. So part D here, so how many moles are produced from 3 moles of H2 and 1 mole of N2? So I'm just going to switch my colors here. So if I have, say, 3 moles of H2 and 1 mole of N2, how many moles of N2 are going to be produced? And hopefully you came up with 2 moles of, NH3 are going to be produced from that. And that's just looking at the ratio there. Now let's make it a little more difficult. So looking at this now, how many moles of NH3 come from 6 moles of H2 and 2 moles of N2? Now, hopefully you'll look at this and realize, okay, the 3 for the H2 here, I had to multiply that by 2 to get to 6, multiply the 1 here by 2 to get to 2, so then 2 by 2 has to be 4. So 4 moles of NH3 will be produced from 6 moles of H2 and 2 moles of N2. Now, again, we're going to just take it one step further here. So now, how many moles of N2 will be required to react exactly with 9 moles of H2? So 9 moles of H2 is what I have, and I want to know how many moles of N2 are required to react exactly with that. Now, hopefully, again, you'll say, okay, well, 3, if I multiply 3 by 3, I get 9. So if I multiply the 1 by 3, I get 3 moles of H2. So what you're doing here is you are applying the mole ratio, whether you know it or not, that's what you're doing. You're applying the mole ratio to solve these questions. Now, when we have nice whole numbers, it makes sense. But then all of a sudden, we put decimals in and people get confused, right? So now, how many moles of H2 and N2 will be required to produce 0.4 moles of NH3. So this is asking me how many moles of H2 and how many moles of N2 are required. So these are my questions here. So I'm going to go through and I'm going to use dimensional analysis here to do this. Now, when you did the questions here, you didn't use dA because they were nice and easy for you, and so you did it naturally in your head. But when we have decimals, often that kind of confuses people. So we're going to do the same math as what we did in the prior questions, but we're going to use dA, so it's just a little easier for us to follow here. So I'm going to find moles of H2. I'm going to do that first. What do I know? I know that I've got 0.4 moles of NH3. Now I've got my conversion factor. Unit that I see here, the moles NH3 is going to go on the bottom. And the moles of H2 goes on the top. And the ratio between those, I get those from the balanced equation, right, is going to be 3 to 2. So 0.4 multiplied by 3 divided by 2 is going to get me 0.6 moles of H2. Okay, now I'm going to do the same thing for moles of N2. Again, I'm going to start out with 0.4 moles of the NH3. Then I've got my mole ratio, so I'm converting from moles to moles using the mole ratio. So moles of NH3, moles of N2 goes on top, and the ratio between them is 1 to 2. And so I end up with 0.2 moles of N2. So I can use dimensional analysis to solve for these here. So let's try this one. This is a different equation. Okay, so your very first step is going to be what? Yeah, you always are going to need to balance, right? So if I put a 2 in front here, I think I end up balanced, right? Yeah. So now, how many moles of chlorine? So I like to write information that's given to me when I'm looking for underneath the equation. It just keeps everything really nice and organized here. So how many moles of Cl2? So moles Cl2 is my question mark. That's what I'm looking for. And I want to produce 0.354 moles of HCl. Now it says here, assume H2 is in excess. What that means is that you've got lots of H2, you don't need to worry about it. So don't even factor it into your question here. Okay, so I'm looking for moles of Cl2. So moles Cl2 equals, I know, 0.354 moles of HCl. Now again, moles HCl is going to go on the bottom. Moles of Cl2 goes on the top, and the ratio between those is from the balanced equation is 1 to 2 here. So now I have to take 0.354, so 0.354, and I'm going to divide that by 2, and you get an answer of 0.177 moles of Cl2. So mole to mole within a chemical reaction, we just have one bracket, okay? Now we're going to add another step in here, so I'm going to rebalance that. Now, how many moles of H2, so moles of H2 is what I'm looking for, are needed to produce 0. Oh, you know what, I messed this up. Are needed to react with, change that. React with 0.12 grams of chlorine. So I've got 0.12 grams of chlorine. Now, as you can see, they bond in a 1-to-1 ratio, right? So the ratio between them is going to be 1 to 1. But again, I'm going to use dimensional analysis just to show this. So I'm looking for what? I'm looking for moles of H2. So moles of H2 is equal to, and now I write down what I know, 0.12 grams of Cl2. Now, so 35.5, sorry, I'm thinking out loud to myself. Okay, so your very first step Again, whatever you wrote down there has to immediately go to the bottom here. So grams of Cl2 goes on the bottom. Now, before you can do anything with the Cl2, you have to work through the mole. So remember, you always work through the mole ratio, always work through the mole. So before I can do anything with the chlorine, it's in grams, I have to get that into moles of Cl2. And so I'm going to get 71, and that number came from the periodic table. It came from 2 chlorine atoms. So right now, if I stopped the problem, grams of chlorine is going to cancel, and I'm in moles of chlorine, but I don't want that. So I'm going to need another bracket. So what goes on the bottom? Moles of Cl2, and on the top is going to be my moles of H2. And now I look at the mole ratio to solve those, and that's 1 to 1, so mathematically it's no difference. And now again, I want to make sure that my units all cancel. Moles of chlorine cancel. I end up in moles of H2, which is what I want. So 0.12 divided by 71 is going to give me an answer of 0.00. And now, how many sig figs can I have? I can only have 2 sig figs because of that 0.12. So my answer is going to be 0.0017 moles of H2. So that's my answer there. Now, so just back here for a second, going moles to moles is going to be our one bracket, right, just through the mole ratio. Moles to grams or grams to mole is going to require 2 brackets always, so make sure you're remembering to work through the mole here. You can do exercise 14 and 15. You have the answers, I believe, or let me just check here. Oh yeah, they're on the website already, so they're up there. So check your work. Again, come to class, be prepared to ask questions, okay? Thanks, everyone.